Hello, my name's William Tippins, or I'm otherwise known as Tootie, by my nickname, and I'm here to do a little technical work for Miss Amy. What we're going to work on today is a typical top fuel dragster frame, which you see here behind me. This type of frame is a tube frame construction. It is a thin wall chromoly steel. It's required by the rules and specifications to be welded with tungsten inert gas, which is a form of welding originally developed in the early 20s and 30s, primarily used in aircraft construction. This is the torch that I'll be using. And this control is a control I hand-made in order to have a more precise control of the welding arc, which is one of the features of this particular type of welding, which makes it very good for this type of work, and also which makes it the kind of welding that the sanctioning bodies who govern these chassis and others like them that race under the different sanctioning bodies that exist in the United States require for a frame like this to be welded. Speaking of the specifications, we'll be showing you some photographs up close of the specifications, which will contain things like what the tubing size has to be, what diameter, what thickness, alloy. It covers some of the welding procedures and that sort of thing. And it's basically a guideline for the constructors such as myself, who would then take that and proceed to construct a frame like you see here behind me that would be completed into a finished race car and raced at the racetrack, but would also be able to pass the technical inspection required for the chassis. And the chassis, by the way, also has to be inspected and certified so that it will pass a certain ET and mile per hour range, which is something that all cars are required to do now. Now, primarily what we'd be working on now is bending the main roll cage assembly and attaching it to the rest of the car. The rest of the car is pretty much fabricated here as far as the frame is concerned. This type of construction, which is a tube gantry type construction, originated in the 30s, mostly in aircraft construction. It was originally welded with acetylene or gas type welding torches. Sometimes helium or hydrogen would be used. Later on, a company by the name of Airco developed what is known in the industry as heliarc. And of course, the reason it's known as heliarc is because in the original manifestations of this particular type of welder, they used helium as a fluxing gas. Now that's no longer the case anymore, although helium makes a very good fluxing gas. It's much cheaper to use argon, which is equally inert like helium and does equally a good job when it comes to fluxing the weld and shielding the weld itself from oxygen contamination in the time it takes for it to cool below the temperature where oxygen can penetrate and bond with the steel and cause a problem with bad weld, a weld that would be considered full of porosity and not suitable for the type of construction that we would be doing here, and especially would be prone to fail in the type of load that it might encounter, not only in its normal functions as a race car, but in particular if it was ever called on to do its ultimate function, which is save the driver's life in a crash situation. You'd have a bad day if the welding on this car wasn't done by someone who knew what they were doing and were doing it by the right and correct procedures in order to make sure that this thin wall tubing, which the thickest of which is about 1/16 of an inch thick, is properly joined and not burn up and not welded in such a way to form a cold shunt, which is a weld that looks good but actually has no penetration. And so it takes a high degree of skill to operate a TIG welding machine. And TIG, of course, stands for tungsten inert gas, tungsten being the electrode material, and the inert gas at this time, as I said before, being argon. Originally helium was used, hence the term heliarc. You will hear this type of welding referred to as heliarc welding or tungsten welding, TIG welding. More nowadays it will be called TIG welding. than it would be heliarc, but the original manifestation of it was called heliarc, as I said before, because they used helium for a fluxing gas. Of course, as it was used in the aircraft industry the same way, and therefore making aircraft able to have a higher level of performance, because for a given power weight to ratio, you're naturally going to have a higher degree of performance if you have a greater power to weight ratio. And so aircraft were, one of the first recognized this. Later on, when car racing started to flourish in the early 20s and 30s, why it was only natural that some types of racing would use these type frames in their construction. Many early manufacturers, such as Mercedes-Benz, the famous Mercedes-Benz Gullwing car, happens to be what's called a space frame, which is simply a tubular constructed frame, similar to what you see here. Although it doesn't look much like this, it still is a triangulated tube assembly, which is what this is. And this type of frame, in fact, is rarely used these days in any other kind of racing. It was originally used in Formula One and other types of racing, which subsequently was replaced by aluminum tubs. And of course, nowadays, all Formula One and IndyCar type race cars are what's called open wheel, and a lot of closed wheel cars too, for that matter, are carbon fiber composite tub cars, and use very little steel at all, except in the points where they use suspension mounting and engine mounting and that sort of thing, would be where the metal parts of a modern day Formula One car would be. But drag cars still cling to this type of construction because it's best suited for the type of loads that these cars see, and also it would be cost prohibitive at this point in time. Although drag racing is very expensive in this day and time, it would still be cost prohibitive to build a carbon fiber tub, and then of course the hurdles in getting it to pass tech and be accepted by the sanctioning body would be something that few men would attempt in a sane state of mind. Although carbon fiber is used in these cars. As you can see here, this is a one-piece carbon fiber seat. Now this is used to save weight, and it's also used because it's extremely strong. And of course carbon fiber has a greater strength to weight ratio than steel. So you can imagine that this is something that would be used in many places on a car like this, and in fact is. As you see here next to me, this happens to be a complete carbon fiber race car body for a late model Mustang Pro Stock car. This body in particular is very expensive. In fact, it costs about $10,000, but it's typically what would be used on a car like that, because in those particular classes, as in much racing, and in most racing in fact, weight is a critical factor. And the less weight you carry, the more the power you have does, and in fact the faster you can go with a given amount of horsepower. If you can reduce weight, then you can take advantage of more horsepower to weight ratio, which gives you a greater performance out of the vehicle, whatever type of vehicle it might happen to be, whether it be a drag racing vehicle such as you see here, or whether it would be a Formula One, Indy, or some other type of drag racing or road racing vehicle. Now what we'll be doing, we'll be going according to the specifications, which we will see later. We will cut some of the tubing that you see here in this rack, which is the right size and diameter to meet the specifications. This tubing will be cut in order to be cut to the proper sizes for the blueprints and drawings and specifications that I have on file and have accumulated over the years of my business that tell me how to bend a particular tube and cut and make it from a straight length of pipe, as we see here, into something that I can use to bend into a roll cage component. One of the first operations that will take place will be the cutting of the pipe after measuring it very carefully to the required length, which would be recorded in my records based on, as I said before, early experience with other cars, and also, of course, in the early years, a lot of my work was trial and error work. But that would be the first step to cut the tube. Now, once the tubing is cut, what's required next is we go and lay the tubing out according to the specifications that I have on file, where I have constructed this type of car before. What this requires is that the specifications lay out the bending dimensions and points of location on this tube so that I can bend this tube as I have bent others before it, and it will come out in such a way that it will fit the chassis and also meet the rules and specifications which govern this type of construction or this part of the car, which is very heavily regulated. There'll be a series of measurements that I'll have to take in order to mark this tube. Now, in this way, I'll find the center line of the tube first. This center line will be primarily used as a reference point for locating the other marks for the bending radiuses, and also when the tube is actually installed on the car, as this primary tube is here that you see behind me. There are several other tubes that must be installed behind it, and those are the ones we're working on now. What we're going to do first is bend them up. These pipes will have to be bent in such a way as to fit the contour of the car and the legal requirements for the driver placement and the location of the driver's helmet after the cage construction, all of which is strictly governed by the sanctioning body in order to determine and assure that the driver will be as safe as possible in the event of a crash. And in fact, this structure you see here in the front of the car, this rounded structure that protrudes out in front of the foot box, is actually a new addition to this type of frame, recently added by the sanctioning body into the governing body which governs the rules over the construction of these type cars. This particular unit is an energy absorbing box, a crushable structure made in order to, because the car is designed to shear away here at these points in an impact. So this structure is designed primarily to absorb energy as it is deformed and crushed against the front of the foot box, behind which are located the driver's feet. And in this way, the driver will be protected, hopefully, from any serious injury in the event of a catastrophic failure. Now, once the tube is laid out to the predetermined bending specifications that I have on file for this type of car, it's marked, then it's taken to the bender for bending. Now, the bender is an over hydraulic bender. It's typically used in this type of construction. There are many types of benders that are used to bend this type of pipe. Many elaborate, much more elaborate than the one I used. When I started in business, this was one of the more elaborate types, in fact, and serves me well to this day. However, there are far more elaborate ones than this now in the market, and far more sophisticated than this bender, located according to the reference marks which we spoke of earlier. The clamp assembly installed, and then the bender started. After reaching a predetermined mark on the bending scale, the tube comes out looking like this. Now, there'll be one more bent like this. This is typically known as the rear helmet bar.